This fire hasn't been switched off in over 10 years. It burns day and night, every single day. Because if it ever went cold, the furnace itself would crack. Inside it flows liquid glass, hotter than volcanic lava. And over the next 10 minutes, you'll watch ordinary sand become the bottle in your hand. This is how glass bottles are made. It starts with 3 simple ingredients: silica sand, the body of the glass; soda ash, which lowers the melting point; and limestone, which makes the finished glass hard and stable. Weighed out precisely, together they form a mix called the batch. But there's a 4th ingredient, and it's the clever one: crushed recycled glass, called cullet. It melts at a lower temperature than raw sand, saving huge amounts of energy. In some furnaces, more than half of every new bottle is old glass, back for another life. The batch is fed into the furnace and melted at around 1,500 degrees Celsius. A furnace like this runs non-stop for 10 to 15 years, holding hundreds of tons of liquid glass at all times. Shutting it down isn't an option. The cooling glass would tear the walls apart. From the furnace, a steady stream of molten glass flows down, and precision shears slice it into identical glowing drops called gobs. Each gob is the exact weight of one future bottle, cut hundreds of times a minute, around the clock. Each gob drops into a blank mold, where a blast of compressed air, or a steel plunger, punches a hollow into it. And here's the twist: the neck of the bottle, the part that takes the cap, is formed first. What comes out is a small, thick, glowing mini bottle called a parison. The parison swings into the final mold, softens again from its own inner heat, and then one strong blast of air blows it out against the mold walls. In under 2 seconds, it takes its final shape, a perfect, glowing bottle. And then comes the shot this whole factory is famous for. Rows of freshly made bottles, still glowing from the heat, marching down the conveyor in perfect formation. Hundreds every minute from a single machine. But right now, these bottles are dangerously fragile. Cooling too fast would lock invisible stress inside the glass, enough to make a bottle shatter on its own, even days later. So they enter the lair, a long tunnel oven where, over about an hour, the temperature glides down in one perfectly controlled curve. At the far end, the bottles emerge cool, clear, and hard. And almost invisibly, a micro-thin protective coating is sprayed on so they can race along high-speed lines without ever scratching each other. Now, every single bottle is inspected. Machines squeeze, scan, and photograph each one at full line speed, rejecting anything with the slightest flaw. And human eyes still back them up. A trained inspector can spot a bad bottle in a fraction of a second. The approved bottles are grouped, swept into layers, and stacked into tall pallets, wrapped and loaded thousands upon thousands, heading for filling plants around the world. And this is why it all matters. Somewhere down the line, that bottle gets filled, capped and chilled, ready for the moment it lands in someone's hand, ice cold and beaded with condensation. From sand and fire to the bottle in your hand, and here's the best part. Glass can be melted down and reborn endlessly without ever losing quality. That empty bottle isn't the end of the story. It's the beginning of the next one. If you enjoyed this, stick around. There's a whole world of everyday things waiting to be taken apart, step by step.